This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. WorkOS is the modern API for authentication and user identity. It enables B2B SaaS companies to accelerate enterprise adoption with identity management and complex features like single sign-on and SCIM. Built for developers tired of using legacy providers like Auth0, WorkOS delivers a unified platform with APIs that can be easily integrated and a predictable pricing model that scales seamlessly with your enterprise motion.
For Software Engineering Radio, this is Sam Taggart. I'm here today with Nicolas Carlo, and we're going to talk about his book, Legacy Code First Aid Kit. Nicolas is a freelance web developer who loves building communities and maintainable software. He organizes the Software Crafters meetups in Montreal, Canada, and shares tips on how to work with legacy code on his blog, understandinglegacycode.com. So welcome, Nicolas.
Hi, Sam. Happy to be here with you.
Great. So the first question is, your book is called Legacy Code First Aid Kit. How do you define legacy code?
That's a good question. So I think most people will define legacy code as some old code, which is not my definition. A popular definition of legacy code is also Michael Feather's definition, which is any code that is not tested. And it's a great definition in most cases because in general, you're working with code that is not tested. I have a slightly different one because I want to capture some nuances. My definition is legacy code is valuable code that you are afraid to change, which may be because it's not tested, but I've seen some tested code that would still label as legacy. And also I like to emphasize first on the fact that if you're dealing with legacy code, it means that you're maintaining a code that is impacting people. It's used in production. Otherwise, you could just throw it away and do over. And it's generally not a scenario. So it's valuable code. In most companies that are successful, you will have legacy code that also pays for the salary. So yeah, I like to think about legacy code as, something you have to maintain. It may be a challenge and painful. We'll talk about that, but also it can really have a lot of impact on actual people.
Yeah, you kind of answered my next question, which was how do you decide when code is worth saving and refactoring and what should be thrown away? But there is another part to that question, which is, are there times when you should take legacy code and maybe it's okay to just slap some duct tape on it and keep it running as opposed to doing a real refactoring and really fixing it up and modernizing it?
Yes. A lot of the answers will be depends, but I'm going to try to explain what it depends on and what to do. For rewrite versus refactor, yeah, in general, rewrite is a bad idea. It has been detailed in many posts, but the only moments where rewriting the thing is a good idea is either you're building something new, so it's actually more of a new product. And there is a talk from a DHH, the creator of Ruby on Rails, who was like, okay, but rewrites are fine, etc. And when you dig into it, you realize, okay, he's talking about building a whole new product based on what you learn on the first product. So in this case, a rewrite is fine. The second scenario is when the rewrite is very small, that it wouldn't be worth iterative approach. And that's the trick for large systems, is to make a rewrite small enough. So you take a small chunk of, for example, a monolith. You take a small chunk that you identify, and your scope is to rewrite that part. And then you have strategies in place to ship to production this new maybe microservice along the legacy code base and have all of that working in production together. So in a sense, you could consider it's a rewrite, but it's a rewrite of a tiny chunk. And that's how you should address, legacy code bases. When is it not worth doing any kind of iterative improvement? I don't know. I would say you probably need to be careful when you do not have a test in place, for instance, about the changes you are making. The first thing you will need to do when you arrive at legacy code base is put in place safety nets. So automated tests, lost documentation, lost knowledge, try to recover that. Monitoring, also logs, all of these, if they're not in place, you should start by putting them in place before you do meaningful changes. Otherwise, you risk breaking a lot of stuff without even realizing it. So that will be the scenario where before trying to refactor the whole thing, I will just do duct tape, minimal changes on it.
Yeah, I remember seeing an interesting post where somebody said something about if you're going to rewrite something, reimagine it. So, like, take kind of like the DHH quote where you take what you learned and you just write something new that does whatever it is you would do now. And I think that can be worth it too. I mean, I think part of the problem seems to be risk. Refactoring always seems like a less risky option in my mind.
Yes, also risk, and we underestimate the rewrite project because it's like with AI. AI can help working with legacy code bases, but as a support tool, if you hope to just use AI to refactor, for example, a piece of code you do not understand, the problem will be you cannot evaluate if that's correct. And that's the same for a rewrite, because how can you tell if the new rewrite actually does what the old system does? And there will be a lot of surprises because all the context you have lost, it will be revealed to you. And it's better to have it revealed progressively in small chunks rather than with a big bang scope. We had that story. So I work and live from Quebec in Canada. And early this year, the part of the government that is responsible for the cars and all this, so they have a system, legacy system, you can imagine, and they went to modernize it. And they announced, hey, we're going to shut down the services for like 3-4 days and we will be back up and it's going to be whole new and magical. And yeah, you can anticipate what happened. It was a disaster. I think that happened in February or something like this. And it created big issues until August. And still today, you can see some cars driving and they do not have their license plates because of all of the delays that happened because of this. And they even estimated the cost of that failed modernization project that cost them multiple millions of dollars because they had to pay people to work extra hours to compensate for the new system not working. So when you talk about a failure and a budget wise, like not only the budget, but also the reputation, like people were pissed off. Yeah, the rewrite was not a good option here.
Yeah. So my next question is sometimes I run into situations where management is reluctant to invest in refactoring. Do you ever run into that? And why do you think that is?
Yes, I think it's interesting because it's one of the main complaints that developers will have, which is we don't have time or like management won't allow us. People just want to ship new features. And I've seen that, yes. The thing is, there are two reasons for that in my experience. The first one is the failure of making a business case for what we're doing. Like when we're talking about refactoring and all of this, it's all technical stuff and we use a lot of technical jargon. You cannot expect, the people driving the business to just understand what that means and how is that helpful. For them, it looks like it's working. Maybe not. They don't see the value and how it connects to the business. But it does. It does, because if you do nothing, you will have a lot of trouble with the business. And the developers can anticipate that. They can see it coming. It's just that they fail to communicate the importance of the work with business words. So there are a bunch of things you can do in that area, which in general goes to try to connect the problem with what it will mean for the business now or later. And that if you have an organization that has SLAs and SLOs, for example, you have it. You have your connection here. If it impacts the SLAs, it will impact your client. It will impact your business. You can see that. If you don't have that, it could be interesting to put them in place, but you can also look at the cost of fixing the bugs. How many bugs are you fixing every week, every month? How much does that cost in terms of salaries? You can look at the opportunity cost. There is a lot of things to look into, and you have to think business. Like, what does that mean in terms of money, reputation, client, etc., that technical implication. So that's the first one. And the second, I would say it's the legacy culture. We talk about legacy code, but in general, like always, the problem is more often with the people. Not saying that the people are bad, but they operate in a way that doesn't help fixing the situation. For example, it's very common that the only thing that gets visible in a company, but in tech in general, it's the makers, the explorers, the new features, the new stuff, always new, new, new. And that's the only thing we talk about. If that's more maybe an advice for technical leaders, tech leads, CTOs, etc. But if you're in a position where you can change that culture, it will be the biggest impact you can have. Because if you start making visible the work that is essential to keep the system afloat, then more people will do it. For example, if the end of your sprint demos, you save 10 minutes for mentioning the people who are upgrading dependencies. Yeah, just that example, for instance, if you can try to have a score of how out of date your system is and plot that over time with a graph and then mention the people who are helping move in the right direction, you will see more people interested in doing that. If you never mention it, no one will just upgrade dependencies until they have to. So changing the culture, it's something you can do if you're in a more leadership position, but it's important to help your engineers make the system more maintainable.
Yeah, it's interesting you mentioned dependency management. I just interviewed Scott Ford not that long ago on Freshly. We'll throw that in the show notes. The other cultural thing that I've noticed is sometimes people are afraid to rewrite code. They kind of view it as waste, like, oh, we wrote this and then we learn more about the problem and now we have to go back and rewrite it. And they think, oh, that's a waste. My opinion tends to be, well, no, we learned what we need, so let's go build what we need. But I don't know if you've run into that or not.
Yes, I remember I read recently Kill It With Fire from Marianne Bellotti, and she addresses this. She said, you need to build the wrong thing the correct way, implying that, for instance, microservices are never the thing to build first because you do not know how your system will actually evolve. If it will evolve, like, I mean, I worked on system on startups and we threw away half of the code base a few months later. So you're taking on complexity. Microservices are harder to manage, especially if you only have a few engineers, for a gain that you do not have and that is hypothetical. But if you go with the monolith route, of course, at some point when you scale, it won't work and you will need to rewrite it. And then that's when people are like, oh, but that code base, like it was too naive. Who wrote that? Oh, I did. Like, of course, past decisions, they had less context about the changes you need to make today. So I also try not to predict the future too hard. It's something you can get better at when you are familiar with the domain you are working with. Of course, you can anticipate where things are going to go. And if you're good, you can make future maintenance easier. But I try not to make things too complicated up front, just the thing that will work now and for the next move. And do not be afraid of, revisiting decisions and rewriting a part of it or redoing it. It's also part of the job. In a sense, it's successful because it means that now you have the scalability problem you didn't have before, which is good news because before you wanted to go from 0 to 1 and now you need to go from 1 to 100. And that's a different thing to do. If you try to take too much complexity at first, like scalability and all of that over engineering, you will actually go slower. And if you're at that 0 to 1 scale, you won't be able to try so many things. So yeah, I agree with you. It's not a failure to rewrite something in the future. It's actually a good sign.
Great. The other cultural thing I see is sometimes organizations save up refactorings and do them all in one big push. And I'm kind of curious about your opinions on that.
Oh, yes. Well, it depends. First, of course, like I mentioned, the culture before. And refactoring as you go, as you implement new features, is something that also should be part of a healthy, maintainable culture. Basically, what I like to do personally is to refactor something as I'm tackling a new feature, because I know what the next move is going to be. So the first thing I do is to, make the change easier. So that's refactoring. And then the change is easier. And now we do the change. And all of that is part of developing the feature. So that's great because I do a lot of refactoring without saying to management that I'm refactoring. That's how the sausage is made. And they cannot tell the difference, but I can tell the difference at the end with the quality of the system. Now, a lot of refactorings can be made like that. However, I've seen sometimes problems that will need more, like we mentioned rewrite before, and the monolith, for instance. Okay, at some point we may need to do the extraction in the microservice, etc. That may be more work. In this case, it may make sense to have a dedicated piece of it. I will still try to, well, in general, I like to tie any refactoring or technical work to a business outcome, because we don't do that just for the sake of it. It's because we want to make a change for the business at some point, and this refactoring, this task enables us to do that. So it will be part of a project. But another scenario that is more frequent is people already have this pile of technical debt, and now they are starting to think about modernizing. And now you may have to do some efforts, like, okay, we need to spend, we had at the previous company I worked with, we had, what's it called? Sustainability week. Like, okay, a week every quarter, the engineers will have the time to tackle on the project that didn't get much love, for example, upgrading dependencies, etc. I think it's less ideal than having that part of the culture of like, do that every day as you go. But when you arrive in a new company or the culture is not here, it's better than doing nothing and just wait.
Yeah, my question would be is how sacred was that week and how often did that week get canceled because there was other priorities?
It's a great question. No, definitely it happened to be moved or to have one canceled. But the CTO was not bad as trying to make it sacred, because he managed to get the use that week for product to think about, the roadmap, the vision, and all
Ah,
of this, which it's clever. Again, ideally, I would rather prefer to have not just the product thinking about the product and the engineers coding, but to have everyone part of that discussion. You have engineers who know the system and how the system is working. Include them in the discussion of what the system should do next, and it will be better. But again, if you're working with a legacy system and a legacy culture, you need to start somewhere. So
yeah, those are some great thoughts. So, talking about the book a little bit more, how would you compare your book to previous books like Michael Feather's books or Martin Fowler's refactoring book?
yeah, comparing to Michael Feather's book is tough. I would always recommend reading Michael Feather's book first, because it's a reference. And also, like his book, he really shares the mindset of how you should approach legacy code in general. There are a few concrete examples, but he also talks a lot about how you approach that kind of code. And this is something that I don't necessarily tackle in my book, for instance. My book will be more, you're currently stuck with a project and you're in the trenches, you need a way out, you need some techniques. And what I did was to collect the techniques I used most frequently and to detail what they are, why they work, and how to apply them in the book. And so that resulted in a 200 pages ebook with 14 techniques. But that's more a toolbox to use when you're in the field, versus Michael Feeder's is more how you should approach legacy systems in general. And I think you should have both. It depends. You mentioned Martin Fowler's refactoring book. It's probably looking more like mine in sense of it's a catalog of refactoring recipes. So it's a book you will go back to. It's not a book you will read cover to cover and then put on the side. It's a book you will get back to whenever you need to do something, and you look for the refactoring move and you apply the steps. It's a bit more like my kit. And actually, in my book, I also detail the few refactoring moves that I use the most when it comes to legacy code. So there is a bit of overlap. But I would say, of course, if you want to become a better engineer in general, Martin Fuller's book, it's a catalog of 50 plus refactoring moves. It's a huge reference. So I would also recommend this one.
Yeah, it almost feels like refactoring is like one small subset of all the tools that you have, because there's a bunch of other tools in there too that are not necessarily refactorings.
Yes. I would recommend another book actually, because we're talking about books and inspiration. So we mentioned Michael Feathers, we mentioned Martin Fowler, of course, two big sources of inspiration, but also Adam Thornhill. So that person, if you don't know him, he wrote a book that is called Your Code as a Crime Scene. That is the most popular one. And there has been a second edition in 2023, earlier this year. But he also wrote another book called Software Design X-Rays, which is an iteration of Your Code as a Crime Scene. I would recommend one or the other, like Your Code as a Crime Scene or Software Design X-Rays, because it's the only book that I know that addresses one technique that is tremendously useful for legacy code bases. And this is behavioral analysis. So the idea behind behavioral analysis is to approach your code as a crime scene. You know, you don't know what happened here. You have lost a lot of the context and the knowledge because developers are gone. There is no test, there is no docs, etc. But you try to grab what happened from what you see. And with software, you have a ton of information in version control metadata, like Git. With Git, you can know who touched what and when, at least. And with that information, that is in general, people don't think about this, but when you use that to combine with your other, static analysis tool, like the usual ones, you combine them together, and that gives you a lot of things you can do, like finding which files to prioritize in terms of refactorings based on the quality, but also how frequently you change these files. You can also identify the part of the code base that some of the developers are expert in, because you can see who contributed the most to which part, which can also be useful for offboarding. If you have a developer leaving the company, it could be helpful to know, okay, which part of the code base do you actually know a lot about? And many other things you can infer. So I detail the hotspot analysis, for instance, that is in my book, is coming from that. It's something I use frequently when I arrive on the system and I want to prioritize what to do, especially on large legacy systems. People are overwhelmed with everything they could clean up. And that gives you a manageable subset of, okay, you should start here. And that's a plan you can present to management, because now you can talk about return on investment. Like if we spend that amount of time on this file, we will have the biggest return on investment for refactoring efforts. Like they understand that a little bit more. It sounds like a plan. So I would recommend this.
Very good. That was actually one of my questions later. So your book lists 14 or 15 tools and techniques. Are all of them language agnostic?
I tried to, yes. Of course, at some point it won't be. So I used example. I think in my book, they may be all in JavaScript, TypeScript. I use the same path as Martin Fowler to use a language that is familiar with most people. But I also try to give examples in other languages or tools in different languages, because it always depends. Not all languages are equal in terms of tooling. Like the .NET community actually has a lot of advantage in that area. Also, PHP has some good stuff, to be honest, but it's not the case everywhere. So I try to mention other tools that could be, if the techniques I'm mentioning, at some point you need to touch the code. So of course, the way to do it concretely, for example, to invert a dependency, it may depend on the language you're working with. Is it more functional? Is it more object-oriented? Is it procedural? So what I try to capture is what to do and what you're looking for. Like you want to invert the side effect, like extract the business logic from the side effect. That's what you want to do. And I show you how you do that with object-oriented code and with functional code. But then you have to adapt. And there are techniques that apply Yeah, regardless of the language. So the behavioral analysis, as long as you're working with version control tooling, you will have that. In general, it's Git. You could also have that with Mercurial if you end up on a system that is still using this, which we're talking about legacy systems, so it can happen. But this will be relevant regardless of the language. And one tip I can share, by the way, when you are doing hotspot analysis, you need to combine the frequency of the change, the churn, with the code complexity. And many languages have something to calculate the code complexity, but if your language doesn't have, you can always use the count of lines of code for every file because, well, it has been proven that it's not super accurate, but the trend of lines of code tend to follow the trend of complexity. So, when you do not have any other tool, that's a good first guess.
Yeah, I really like the hotspot analysis tool, but I find I don't end up using it a lot, mostly because a lot of the legacy systems I encounter are not actually in source code control. So that's like the first step. So there is no history to go back and look. So hopefully in the future, I'll be able to use that a lot more. But also, the thing you mentioned about doing examples in one language and kind of have to extrapolate them to others. I mostly program in LabVIEW, so I'm very used to doing that because there are very few books written in LabVIEW. Most of them tend to be Java or C# or something. So, next question. Which of the tools in the book do you happen to end up using the most?
That's a good question. Well, the hotspot analysis, I use it a lot when I arrive on a project because I'm doing consulting. So when I arrive on a new code base, I use that as part of the tool. I talk to a lot of people and I also use that to see if that confirms what I'm understanding and also give me hints about who to ask and stuff like this. But that's situational. It's not something I would use all of the time. When I'm coding, which is the case today, the techniques I resort to the most often are the ones about refactoring the code. So there are a couple of refactoring moves that I show, but yeah, inverting the dependency, separating the business logic from the side effects is something I do all the time. And also the automated refactorings. It's interesting because I found that a lot of developers I've worked with, they don't know what their editor can do for them, especially in terms of code automation, like refactorings. Some people if they have, again, it depends on the language, but if you're working, for example, with JavaScript or PHP or whatever, and you use IntelliJ editor, in general, that editor can transform a lot of the code for you. And it's much faster to use it and much safer to use it rather than trying to do the moves manually. But even sometimes, I work with people in JavaScript and they use VS Code. So I use VS Code too. And VS Code is capable today of renaming a symbol across the code base automatically and handle the renames of everything. And yet I see a lot of people just, go for the first occurrence, change the name, and then trying to find the next occurrence, change the name. And it's first, it is slow because it takes a while to update all the references. And it is dangerous because if you miss any place in JavaScript, you may miss some places. You have introduced a bug. So yeah, automated refactoring is something I use all the time. And I find myself teaching all the time that, hey, you can use this F2 in VS Code to rename automatically. Or did you know that your WebStorm can actually refactor this for you?
Yeah, I imagine that will only get better with AI tools now. Have you noticed anything in that front? Does that show any promise or is it still in its infancy?
It's a big 23 topic. Earlier this year, I worked a lot. I was curious about this, what AI can do to work with legacy code. And I found some promising stuff. For example, there are some tools that can help you understand what the piece of code is doing. I said earlier, the difficult part is how can you assess that it's correct or not? So you should not just take it for granted. But in my experience, it's a good support. It helps you grasp a few things much faster And if you use that combined with other techniques, it can get you code much faster. I have seen actually some startups today are going on for the is going to write the test for you. I give a little hand here, and my conclusion today, it's promising. There are two main problems here. The first one is, how can you tell that the tests are fine or if there is any other test missing when it's generated automatically? That's one difficult part. The second is the quality of the test. When the code is a bit complex and things are tangled together, you need tests that will allow you to refactor that code after. If you write tests mocking everything and making everything super rigid, it's going to be difficult for you to refactor the code after you have the test. So these are difficult, but I've had good success with using such a tool to find test cases that would have taken me a long time to realize. Like, I don't know this piece of code. I would like to write some tests before I do anything with this. And having AI ingest that code and suggest test scenarios for me was actually very helpful. It sped me up. And the last piece that I've seen is using AI to refactor the code for you. So you give it a legacy piece of code, tangled spaghetti mess, and you ask it, hey, refactor this, make it simpler. And here, well, yeah, sometimes it may get it right, but I tried it on things where I had the test, so I could tell whether or not it got it right. And in general, like, I think most of the time it had at least one issue, one regression somewhere. And again, the problem is when you do it for real, you cannot, if you do not have your strong test suite before, you cannot tell. So I would not use that yet, unless you have good tests. If you first have the test, then I could use AI to refactor some code eventually. The second thing, and this is ongoing experiment, is combining both. Combining automated refactoring tools. Like the automated refactoring tool, we will parse the code into an AST, do valid transformation to that tree, and then generate code again. AI will be generative. The idea is, okay, maybe we can have AI suggest refactoring moves and connect that with your editor who can do the refactoring moves safely. And that is interesting because I think AI can be really good at suggesting creative stuff, especially if you're not, an expert in refactoring and you haven't read all the 50 plus refactoring from Martin Fuller's catalog. So AI can do that for you, but you don't risk it on AI hallucination to transform your code base. You lean on your editor that you can trust, that knows the structure of your code across the project.
Yeah, that's really interesting. Sounds promising. So going back to the question of which tools you end up using most, I found one of the tools I end up using a lot, almost unconsciously, is the naming. Starting out with some name and like, generally I'm okay at coming up with something close, but usually I end up like, just as I'm doing it, I'm just constantly iterating on the name. And I thought that was rather interesting.
Yes, this one was inspired by Arlo Belshi. He wrote a series of naming as a process is the name of the series of blog posts. And it's interesting because the idea, like, naming is hard. Most people will agree with that. It's a very, very difficult problem to get names right. And people try to get the name right at first try. Pretty much like we said earlier, like rewriting something feels like a failure, etc. But same with the name. Actually, no, because you learn as you do. And the more you learn, the more you can improve the names. And so that's what Arlo is describing. And that's also what I picked, because you can improve names progressively in a legacy code base.
Yeah, I also find naming leads you to refactorings. Like you end up naming something that's like do A and B and C, and you're like, oh, well, those are really three concrete things. Maybe we should extract some methods there or something. So my next questions is, which tools do you think are least familiar to developers?
For working with legacy code, the
Yeah.
tools they don't know much? Well, in my experience, the behavioral analysis tools in general, like the thing I mentioned earlier with Adam Thornhill, all of that, every time I present it somewhere, people are discovering this concept. So It's a powerful concept, and yet it doesn't get as much love. Like every developer has heard about refactoring from Martin Fowler, probably about the working with effectively with legacy code. But Adam Thornhill, that's also why I wanted to mention him. So he wrote the books, he did a lot of study around that, some open source code, and now he has a SaaS software code scene. So it's free for open source projects, so you can try what it can do, but you pay for it for a legacy project, for a private legacy project. But I think it's worth it because you get everything that he mentioned in one tool you can use on your software. And this is something people don't know. And yet, again, when we're talking about legacy systems that are under version control, so sorry, not your case, but if your system is under version control and it's critical, it's in production, used by millions of people, bringing like a lot of money, but it's all that needs to be improved, I would spend some budget on CodeScene to analyze and give you a lot of insights about what you can do, where you should start, see who knows what, where, who interacts with who, does that align, that the code structure aligns with your organization. Also, will you find coupling between two repositories in different languages that you were not aware of, all of that. So behavioral analysis and CodeScene as a tool are not very well known.
Yeah, I have a friend who refers to that as code archaeology, which is very interesting because you're looking at all the artifacts in the repository. So I think partly because I had talked to you before I read the book, that was actually not new to me. But one of the things that was fairly new to me was the Mikado method, because the only time I've ever heard of that was Manning, I believe, has a book about it. But that's the only time I'd ever heard that mentioned. How did you stumble upon that? And can you talk a little bit about what the Mikado method is?
Yes, the Mikado method. It's an interesting technique. I don't use it all the time, but I resort to it when I have something to do that is unknown in terms of scope. So more frequent when the task to address is big or I am new to the project. So the idea is you want to achieve something. You write it down, could be on a piece of paper. You write down your objective. I want to upgrade that dependency. Okay, that's your target. Then you set a timer. You try to keep it short, like 10 minutes, 15 maybe, but I would not advise to do more than 15 minutes, and you will understand why. So you start the timer, you try to complete your task within that time box. And what happens is you will fail, of course, because if you could do that within 10 minutes, you wouldn't think about doing the Mikado method in the first place. So yeah, you fail. It's normal. Your timer rings and you have not completed what you wanted to do. You have maybe some work in progress, or maybe you'd have nothing and you just went and discovered a few things about the code. So when you're at that point, you should stop. You should think about where you are. What have you discovered? Are you blocked? What do you need? And you write it down on your paper. You try to find blockers for your main objective. Or maybe you are breaking down what you need to do into smaller parts. You write them down as nodes on your paper and you connect them to the main node, your main objective. Then you pick one of these new nodes, so a subtask, if you will. You start your timer again, and before you start over, you git reset -- hard, everything. If you really cannot resort to doing that, you should at least stash everything. The idea is that if you happen to change code in that time box, you need to revert that change because you need to start fresh from a fresh state on a smaller subtask. And you repeat. You do that again. You may fail again, like 10 minutes won't be enough to do that subtask. So you repeat. You write down what you found. You have a subtask eventually. And at some point, you will be able to complete something within this time box. Maybe in 2 minutes, you will be able to do that little change you wrote down. And that's a different process. So at this point, you're successfully making a change within 10 minutes. When you do so, you can do a commit. So you will have small commits by design and cross it off your Mikado graph. The micadograph is what you're ending up with on your piece of paper. Or you can use, if you are using online tools, I suggest you go for mind map tools because they're really convenient to draw this kind of graphs. So you cross it over and then you pick something else that is low in the tree. The idea is that you start with the smaller tasks first that are requirements for doing the bigger ones. By doing the smaller ones, you will finally be able to tackle the bigger one because all of the blockers will have been addressed. And now it's trivial to make it done within 10 minutes. And so you really have two phases. The first one is you're discovering everything you need to do. It's like you're resolving the dependencies of your task that was unknown. And it's good when you do the micadograph because you have a visual artifact of it. You know that tonal effect when you start working on something and then you have a lot of change going on and you don't know how far you are from the end, but you cannot revert back to the beginning, nothing is working, etc. The micadograph is the solution for this. You're doing the same thing, but the difference is as you move with this discipline, you have a clear view of everything that you need to do, which you can discuss with the rest of your team because maybe you realize that the task is too big and you can split into smaller stuff. And eventually you have a second phase, which is, okay, now I'm resolving all of the issues until the end. And that feels good because it's basically you have a to-do list and you just follow it and cross everything. You can get in the zone while doing this. It's really good for the brain. So yeah, in general, I would use it, I told you, when I'm not sure about the scope of what I'm trying to achieve. And if I see someone in stand-up 3 days in a row saying, I'm almost done, I know that, okay, that person next time we need to pair a little bit together. So I will show them this technique because that's a solution to I'm almost done every day without any concrete detail.
Yeah, it's one of those things. Sometimes I set out to use it, like I know the task is big or I know it's going to touch a bunch of different pieces. But sometimes I start on a task and I think it's going to be a quick task. And if after 10 or 15 minutes, I'm like, I've touched like 3 different modules now. And oh, I've got this other thing that I don't know about. I'm like, okay, stop, wait, draw it out. And it really helps clarify things, I think. I find it very
Yes,
useful.
but it's also very difficult. Like the part where people struggle the most, it's the revert your changes part. And that's why you should not do more than 10 or 15 minutes. Because if that's 10 minutes of work, that's fine. You can throw it away. But if you've been working for an hour, you do not want to throw everything away. And yet, I think it's a great practice to practice throwing away code. I did that on Kata, but I did that on code. Like following the Mikado method, you do that on production code. You try something, it does not work, and you throw it away and you try again. And usually when you try again, it's better.
Yeah, very true. So speaking of struggling, out of the tools in the book, which ones do you think developers struggle the most with?
It's a good question. I think, well, I mentioned in the book, I talk about doing smaller commits in general. And that's an advice, even if you don't know it by the name I use, like micro committing. I think that's an advice most engineers have received at some point. And yet, even myself, I struggled to actually do that. And the reason was, okay, I know I should do small focused commits, but when I'm into it, when I'm working, I do not think about doing a small commit. It really takes a lot of discipline and learning the moves to have like small refactoring moves. For example, there are good candidates for making a small commit. You do a little extract function, you do a commit, and that's out of the way and you can iterate. I would say that's a technique people struggle the most with in general because they know it, but in practice, how do they do that? The Mikado method is a good solution to that because by design, the commits you will do, they will have less than 10 minutes of work. So that's one. I would say practicing refactoring moves. So I mentioned a few incremental refactorings you can do. These will also help you do smaller commits. And in general, the technique I used personally to get used to, like to train myself to do smaller commits was to use, I use a gym timer. I don't have it here, but I have a gym timer. The difference with the regular timer is that it's a timer that buzzes a set interval like every 5 minutes, for instance. And I remember putting that in my pocket. And every 5 minutes, I will get a little buzz in my pocket. And that will just remind me of, hey, maybe I should stop and do a commit. Maybe not. But it was a nice way to have a constant reminder while I'm working that, okay, maybe I should do a small commit here. I don't use it anymore today because I found myself to more naturally, I have the habit of now like thinking about, hey, I should do a commit. But if you're struggling taking a new habit, for example, drinking water frequently, a gym timer, it's an actual very affordable way of getting into a habit.
Very cool. That's great advice. So, my last couple questions are what have you learned since writing the book?
That's a good point. I wrote the book 2 years ago. Well, actually, almost three. And I still use most of the techniques that I described. So because I did that work earlier this year, I was like, okay, from the 14 techniques, am I still like, are they still relevant? And they do. So that's the great stuff about legacy code is in general, what you're talking about still applies long time later because we still have to work with legacy code bases and the concepts are the same. What I learned, of course, everything that we talk about regarding AI wasn't something in the horizon 2-3 years ago. So that may change. There may be new approaches, a new way to combine the traditional techniques with like powered by AI could be interesting. Then I had interesting insights about approval testing. So approval testing is a technique I describe as a way to cover existing code with tests fast. But Emily Page actually did a couple more follow-ups on this to show that you can use approval testing also to produce new code. And this is not something I had in mind first. And I realized later that in some occasions, yes, if you have a good printer, you can actually, in the book, I said you should ditch these tests as soon as you can, but maybe not. In some cases, it may not be the case. So that will be a change I will make.
That was a misconception that I had too about approval testing. So, yeah, you're not the only one.
No, I think Dave Farley also presented approval testing the same way in a recent video. And I was like, you also think you should get rid of this test. But it, again, as usual, it depends. In my experience, it depends on the quality of the printer. And if you can come up with a printer that makes sense and make the snapshots useful from a human perspective, it's more than just a anti-regression test.
Yeah. If anybody wants to learn more about approvals, I did an interview with Llewellyn not that long ago that was also on SE Radio. We'll throw the number in the show notes. Very great stuff. One last question, and that is, have you learned any new tools since you wrote the book or?
Yes, I tried and failed a little bit, but something that is, okay, really niche at this point, and it's called moldable development. And you can find the only tool I know that is doing that today is called Glamorous Toolkit. And there is a small community of people doing that. It's a completely different way of thinking about development. You still code, but you shape your coding environment, so your editor, with code, so it adapts to whatever problem you're solving. It's a bit difficult for me to explain because I'm not an expert in this, but I've practiced it a little bit. And that's interesting because, yes, indeed, you can craft, like your editor serves as documentation and visualization tool of your code base at the same time. And I think there is a potential here for some legacy systems because it's totally part of what that thing can do, discovering a domain and making it visual, explaining it. And as you are discovering the domain and the code base and the system, you can build visualizations right within the editor you're using and iterate from that and then grow something. The problem is it has a cost. I don't know anyone who knows how to use that and program with this. It's based on Faro. So like also, I don't know a lot of people are familiar with Faro and Smalltalk, but it's an easy one to grab though. So it has a huge entry cost. It's something you need to learn, and it's not something small. But if you're working on a very old legacy system that is critical, that doesn't have good tooling, for instance, like if you're talking about JavaScript, yeah, you have tools for static analysis, you have tools for dependency graphs, etc. If the language you're working with doesn't have all of this, it has a huge impact. For example, you're working with healthcare or, I don't know, finance or something that is not just, a legacy web application. It may be worth it. And I'm sure people who are more experienced than me will say, no, you can actually use it in much more context. For the moment, my position on it is there is a huge cost, but there is a very interesting benefit. So in some situations, I may consider using that. And that's something I wasn't aware of when I wrote the book. I would not include it yet in the book because it's not something I use yet. But if people want to broaden their mind and about what's possible to do, I would encourage you to look at Glamorous Toolkit.
Great. Thank you so much for sharing all your wisdom with us and for writing the book. I personally have read it and I find it quite useful and I refer back to it a lot. So thank you.
Well, thank you for having me. And I always like to share a lot of the techniques and tips I collect, all of the tools. I'm like a magnet that tries to grab all the resources on that topic, and then I put them on the blog and on the book. So thank you, Sam, for having me.
For Software Engineering Radio, this is Sam Taggart. Thank you for joining us.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.